announcements from American Clay this afternoon. Basically, what we have been doing over the past year and what we introduced last year at Greenbuild was a series of test units that we had produced in Albuquerque to sort of help start quantifying the potential energy savings that people have been reporting to us as our customers. When that first started, I was somewhat skeptical as to the fact that a veneer plaster by itself could potentially influence the temperatures within a house or influence the interior climate of a house to the extent that we had expected or had not expected just from that veneer. And so basically what we did is we created a series of test units. Each of those test units was built identically as far as the construction goes. We changed the exterior for 2 of the units, and the other 2 units had a different finish on the outside. All the walls were 2x4 construction with an insulation, an R13 insulation. And then on the interior, one of those units would have paint, the other units would have clay. We positioned those in one zone within our facility, all within the same microclimate right there. We monitored the ambient conditions, and then we had a sensing unit inside each of the units, identical from one another, to monitor both humidity and temperature for ambient, and then humidity and temperature for the interior for the units where we had them positioned. It was interesting because at first I didn't expect there to be much of a differentiation. I expected maybe 2%. As we monitored those consistently, day in and day out, hour by hour, the clay and the paint both contributed differently to the interior fluctuations. The clay consistently was cooler, and the paint was consistently warmer, and vice versa, consistently colder in the evening times and consistently warmer on the clay side. So basically for every day over the past 10 months, we've been pulling out a graph data comparing ambient temperatures and humidities to the internal variations. As you can see here, the clay is the green, and the paint is the green, and the clay is the blue. When we looked at what that meant, and we looked at the fluctuation swings, paint had a differentiation from the outside, but the clay was considerably more stable than the paint. So we saw as high as a 12% greater stability in the clay, and as it's over the past year, we have seen it become more consistently 6% more stable than a painted wall surface. What we are looking at next is, was that just a mass? We all know that there is a mass component for earthly construction that usually takes place when you look at compressed earth block or adobe or cob types of systems, but you're looking at usually at a minimum 8 inches up to 3 feet thick sometimes if you look at historical construction. And we started to notice one of the things that we are going to continue to monitor and what we are going to start introducing is a more realistic humidity differentiation when we look at the interior environments. Meaning, when we live in a house, the humidity isn't just influenced by the external ambient conditions. It's influenced by us breathing, it's influenced by showers, toilets, cooking, all of those components. And that is one of the things that we've seen over the past year, is as the humidities become more consistent within the spaces over time without any interaction within the spaces, the fluctuations between the paint and the clay have become closer together. So what potentially is because the clay itself isn't much of a mass, it is literally maybe 3/32 of an inch thick. There's not much you can think of as far as a mass component goes. We believe that there is something else contributing to the stability of that interior space when we compare it between paint and clay. So what we have left, when we look at that, is how we incorporate how we quantify the potential energy savings of the spaces compared to just a painted surface, and what are the key components that contribute to those fluctuations or those variations between the clay and a painted surface. I think one of the more intriguing aspects is the fact that with it just being a veneer component, that we have a interaction between the water and the clay that basically, if you think of water, you think of liquid water, you think of water vapor. There is, when the water heats up, there's energy that is used to transform it. The energy is absorbed into that water, and we actually don't see a physical change or a temperature change in the space around it because the water is taking that energy up. When it condenses, that energy is given back into the space. When it's interacting with the clay, we believe that there is an exchange of energy between the water vapor and the clay itself to both heat and cool the interior space. Over the next year, we're going to continue to monitor those and really get to a quantifiable aspect.